Hello students, how are you? I am Pushkar, Master Teacher in Chemistry at Vedantu, and I am discussing JEE Advanced 2021 Chemistry paper. Here is a question, which is question number 7 and 8. It's a difficult question, and question belongs to thermodynamics. In this question, an equilibrium is described. X solid is in equilibrium with Y solid with Z and Z gas, and a plot of pressure of Z versus 10 to the power 4 by T is given. And this pressure is the equilibrium pressure. Pz is the equilibrium pressure. It is given. Pz is the pressure in bar of the gas Z at temperature T, and P naught is equals to 1 bar. So obviously that's equilibrium pressure, and the graph is a straight line graph, and it has been given that dln k upon d1 by T, as you can see here, is equals to delta H naught upon R. So we have to use this information to calculate delta H naught and delta S naught. So how to approach this problem? To approach this problem, our strategy will be, first of all, to find the slope of this graph. And to find the slope of the graph, the most important thing which you have to keep it in mind is you have to convert this number into 1 by T. So 12 is equals to 10 to the power 4 by T. This means 1 by T is equals to 1 12 into 10 to the power minus 4, which is 1.2 into 10 to the power minus 3. Similarly, at this point, 1 by T is equals to simply 10 to the power minus 3. So these two values, keeping in mind these two values, we can find the slope on this graph, which is equal to minus 7 minus 3 divided by 1.2 into 10 to the power minus 3 minus 10 to the power minus 3, which is coming out to be minus 4 divided by 0.2 into 10 to the power minus 3, and which is equal to 4 by 2 with a negative sign into 10 to the power 4, and which is of course minus 2 into 10 to the power minus 4, and this must be equal to minus delta H naught upon R. So from this you can calculate delta H naught is equal to 2 into 10 to the power 4 into R. Another interesting thing you can see here is delta H naught is positive, as reflected by this fact that when we are moving from this side to this side, the temperature is basically decreasing, and the equilibrium constant value is also decreasing, and which means that on decreasing temperature, if equilibrium constant is decreasing, that means this reaction is what? An endothermic reaction. So it's confirming this viewpoint that delta H naught is an endothermic, delta H naught is positive. Now, in order to calculate delta S naught, we need what? Delta G naught. And to get delta G naught, we have one point, the values are given. From this point, we can calculate. We have to find out what is the temperature here. So if 1 by T is 10 to the power minus 3, so T at this point is equal to how much? 10 to the power 3. So we can also find delta G naught in this manner. Delta G naught at this point is equals to minus RT and ln of K equilibrium. And here K equilibrium value is minus 3, ln of K equilibrium is minus 3. So basically this is minus RT into minus 3, which is 3 RT is delta G naught. But temperature here is 1000 Kelvin, so this is basically 3000 R is equals to delta G naught at this point. Now we have delta G naught and we have delta H naught, so we can quickly calculate the delta S naught value. So let us see how to solve it. So from this we can see that delta G naught is 3000 R, and now we can calculate, put it in this equation to get the value of delta S naught, which is coming out to be 17 R. By simple rearrangement, we'll get delta S naught is equals to 17 R. Now, we have to put the value of R, which is given 8.314, and round it off to the 2 decimal places. So if you do it, you're going to get 166.28, that will be the answer for delta H naught, and 141.34, that will be answer for delta S naught. So I hope that you enjoyed the solution and understand the solution. So stay tuned for other questions. Thanks for watching.